Here's an example where we're asked to find the standard deviation. So it says that right here. Find the standard deviation from a set of from a list of raw scores. So our setup says students were asked how many hours they study per day. The results given below. Find the standard deviation. Now the way that you do this is our formula for standard deviation is very simple. The standard deviation is just the root of the variance. So then how do we find the variance? Well, the variance is the sum of squares over n. So n is just a count of how many data points there are. There's 1, 2, 3, 4, 5. That's easy. But how do we get the sum of squares? Well, the sum of squares is equals to the sum of squared deviations. Actually, that's it. It's just the sum of squared deviations from the mean. So that means we need to know what the mean is. And so to get that, I'm just trying to show you all the steps that are required here to figure out that one final answer. Our mean is the sum of x over n. Now that's easy enough. We can just do that right here. The sum of x, we already know that n equals to 1, 2, 3, 4, 5. N equals to 5. But what happens when we sum these scores up? Well, 2 plus 1 is 3, plus another 2 is 5. This brings it to 8. Another 8 makes 16. So I've got 16. My mean is going to be equals to the sum of x over n. So that is 16 over 1, 2, 3, 4, 5. And so let's see, what is that? That's 3.2. So my mean is 3.2. 16 divided by 5 is 3.2. So we've got our 3.2. That's what goes in here. So each time we work this out, we're going to be doing x minus the mean, which is x minus 3.2. So that's how I find my deviations. So I have to do my individual deviations first. Remember, we have to make use, when we've got a complicated formula like this, where we've got a number of things happening. Let me put that over here. Sum of squares equals to the sum of x minus the mean squared. There is summation, which is really just adding. There are brackets. I've also got subtraction. I've also got an exponent. You need to know what the order of operations is. So there are brackets first, then you have exponents next, third you have division, then there's multiplication, after that addition, and finally at the end subtraction. Now it's going to come up quite a bit, however, that you're going to see me doing subtracting right away. Subtraction happens because the first thing I need to look for are brackets. And in this formula here, you'll see that we've got brackets that contain subtraction. So that means that I have to deal with the brackets first. I have to do with whatever's in the brackets first. It's x minus the mean, each x minus 3.2, and so that's going to be 2 minus 3.2, that's negative 1.2. 1 minus 3.2 is negative 2.2, and so on. Negative 1.2, 3 minus 3.2 is negative 0.2, and 8 minus 3.2 is positive 4.8. If I've done this right, it has to come out to be 0 when I add them up. So let's see if that works. 1.2 plus 2.2, that makes 3.4. Add another, or take away, these are negative, so let me rephrase that. Negative 1.2, take away 2.2, I'm at negative 3.4. Take away another 1.2, I'm at negative 4.6. Take away another 0.2 negative, that is negative 4.8. Add a positive 4.8, it totals up to 0. So far that's working out. So I've dealt with the subtraction that was inside of the brackets. The next thing that happens after brackets is, I've already dealt with subtraction. After the brackets is exponents. I have to take each one of these and raise it. Let me do that in a different color. I have to raise it to the power of 2. So I need to square each one of these. So negative 1.2, when you square that, you get positive. Every time you square anything, it's a positive. It's 1.44. 2.2, when you square that, it's 4.84. Negative 1.2, it's the same as what we had up here, 1.44. Negative 0.2, that's positive 0.04. 4.8, that gives me 23.04. So now I have dealt with the exponents. The only thing left, there's no division here, there's no multiplication, the only thing left is addition. So I'm now going to add that column up. That's going to give me my sum of squared deviations, my sum of squares. And when you add up this column here, it comes out to be 30.8. So we found the mean, we found our sum of squares. Now we can put the sum of squares here into this formula for the variance. We have to find the variance first, because once you find the variance, you put it here, take the square root, and that'll give you the standard deviation. So my variance, let me make a bit of room here. My variance is the sum of squares over n. The sum of squares we just worked out is 30.8. We know that n is 5. We have 5 observations. So our variance comes out to be 6.16. But they didn't ask for the variance. They asked us for the standard deviation. So we have to take the root of this value. Now, why would we want to do that? Why would we want the standard deviation? Well, think about what it is that we're looking at here. Students were asked how many hours they study per day. So these are a measure of hours. What is this? 6.16. What does that mean? Well, this is a measure of variation. It means that there is some variation. It's not a 0. But in reality, what this means is this. 6.16 is measured as hours squared. So the variance in this set of data is 6.16 hours squared. What does that mean? That's not the sort of thing you would ever try to express to someone, a squared quantity. It really isn't an easily understood idea. Instead, what we would like to talk about is the average or the standard deviation. On average, how close are people to the average? So if the average amount of hours spent studying per day is 3.2, so about 3 hours and a few minutes, how close is each individual to that value? Are they clustered tightly around that, or are they all over the place? That's not what the variance tells us. In order to get that kind of a measure, we have to work out the standard deviation. The standard deviation is just the root of the variance. So it's going to be the root of 6.16. That comes out to be how much? 2.48. Now this is easier to understand. This is not measured in squared hours. This is just measured in hours. And what it's telling us is that if the average is 3.2 hours spent studying per day, most people are within about 2.5 hours of that figure. So that tells us that some people are spending almost no time per day. Here, we've got somebody who has only an hour. Other people are spending almost double that, like 3.2 plus another 2.5. That brings me up quite a bit larger. Now, there's somebody that's spending quite a lot more hours, 8 hours. That's more than double 3.2. But the standard deviation doesn't tell us any kind of limits. It just says typically how close are people to the average. Look at our deviations. We've got people that are within about 1 hour, 2 hours, 1 hour, less than an hour, more than 4 hours, almost 5 hours. But on average, somewhere between being within 0.2 hours all the way up to being close to 4.8 hours, somewhere in that amount of hours that you are away from the mean, somewhere near the middle is 2.48 hours. That's what the standard deviation is doing. It's telling us if these are the size, if these are the deviations from the mean. Some people are within about 5 hours, some people are within about 0.2 hours, then typically people are around 2.5 hours away from this average. That tells us how clustered around this central tendency we can expect the data points to be. So that's how I check my standard deviation. I have a look at the standard deviation, then I look at my list of deviations, and I decide, did I do the math right? Does it look like this number here is about an average of the size of these numbers? It's not actually going to be the proper average of 1.2 plus 2.2 and so on. It's just going to be around the average. Because remember, we didn't just add up these numbers and divide by 5. We squared these numbers, and then we took the square root of our result. So it's not quite the same. But this should be, this answer for the standard deviation should be close to the average of these values here. That's how you can check your math. So that's my answer. Standard deviation is 2.48 hours.